Hello everyone, welcome to Frame and Flow. In today's tutorial, we're going to learn how to use physics to create this beautiful simulation. Let's jump right in. Before diving into our blueberry project, let's quickly review how the physics simulation works in Spline. To access the simulation, we first need to enable it. In the scene properties, go to the simulation section and turn on physics. Once enabled, a physics section will appear for every object in your scene. In the scene, we have 3 cubes grouped together. Let's explore the options available in the physics section. First, you can enable or disable the physics simulation for each object, or use visibility settings to determine whether physics applies to an object. Next, we have the children setting, which offers 2 options, fuse and separate. When set to fuse, all child objects of the parent act as a single unit. To demonstrate, let's change the parent's body type to dynamic, which we'll explain in a bit, and see how the 3 cubes behave. As you can see, the cubes are fused together and behave as if they are one object. On the other hand, if we choose separate, each child object is treated individually. Now we can control each cube separately. Let's change each child's body type to dynamic. Now in play mode, the cubes move independently. Next, let's discuss body types. There are 2 options, positioned and dynamic. The position type makes the object static, meaning it doesn't respond to gravity. In play mode, objects set to positioned remain stationary, while others react to gravity. When using positioned, we don't have many settings, but when we switch to dynamic, several additional options become available. The first one is the collider setting. You can choose between simple and precise. The simple collider is faster to calculate, while precise is more accurate but may slow down your scene. Start with simple, and only switch to precise if you encounter issues like objects penetrating each other. We then have weight, which determines how heavy your object is. Increasing the weight makes objects fall faster, while decreasing it slows them down. The gravity scale acts as a multiplier for the scene's gravity, allowing you to amplify or reduce its effect. For example, setting it to 10 makes gravity 10 times stronger. Friction controls how much an object slides on a surface. Higher friction reduces sliding, while lower friction increases it. To illustrate, let's place the blue cube on top of the red cube. In play mode with default friction, the blue cube stops after a short slide. But if we reduce friction to 0 and go to play mode, you'll see the blue cube slide freely. Next, we have damping. Damping reduces the energy of an object, making it fall more slowly. Finally, we have bounce, which determines how much an object rebounds. Increasing the bounce value makes objects springier. You can also control object movement and rotation along each axis. For instance, if you want a cube to move only up and down, disable the X and Z axes in the movement settings. Now, if we go to play mode, you'll see the cube only moving up and down. Similarly, you can limit rotation in specific directions as well. Now that we've covered the basics of physics, let's create our blueberry scene. To create this, we need a few elements. First, download a blueberry model from Sketchfab. I've included the link in the description. Next, grab a soda can model from the Spline library. I used the Red Bull soda can. Then I used AI to generate a simple texture for the can. As you can see in the model, the label isn't perfect because I only need the front of the can to be visible. Finally, we have the floor, which is just a simple rectangle. Now let's hide our can and start distributing our blueberries. We are going to use the cloner tool for this purpose. If you're unfamiliar with the cloner, check out our previous tutorial where we discussed all of its settings. You can find the link in the description. Let's change the cloner type to grid and increase the count number for each axis. As you can see, the blueberries are very uniform. To fix this, let's enable randomness and tweak the position, rotation, and scale settings. As you can see, they look much better now. Next, in the Physics tab, set the Children option to separate so each blueberry behaves individually. Then go to the blueberry mesh and change the body type to Dynamic. Now, if we go to Play mode, you'll see our simulation working. However, you might notice that the blueberries behave slightly explosively. This happens because of overlap. Let's reduce their size to fix this. Next, let's prevent the blueberries from falling off the edge. To do this, we'll create walls around the floor using a box. Adjust its size and duplicate it for all sides. Since we don't want to see these walls, let's set the material opacity to 0 and turn off shadow casting and receiving for all of them. Next, group the boxes and ensure their body type is set to positioned, as we don't need them to react to gravity. Now, let's add animation to the soda can. First, rotate it 90 degrees and position it below the blueberries. Next, create the second state and move it upward. Then, create an event, choose Transition, and adjust the timing. Also make sure the can's physics are set to Position and Fuse. Let's test the setup. It looks like we can adjust the spacing between the blueberries a little bit for a more polished look. I think it's good now. For added realism, enable ambient shadows and effects like bloom, brightness, and contrast. These enhancements are covered in our previous PS5 controller tutorial, so if you haven't watched that yet, make sure to check it out. And that's it. This is how easily you can create a scene using physics simulation. I hope you enjoyed this tutorial. Please don't forget to subscribe, like, and comment. Thanks for watching, and take care.